Okay, in this situation in the Institute, we're looking at one object pushing into another object. So we've got two boxes. We know the mass of each. So one's a 34 kilogram, one's an 87 kilogram. They're being pushed along a frictionless surface, so we don't have to worry about friction in this problem. The pushing force is the same. So we don't know what this pushing force is. The pushing force in each situation is the same. So in situation A, it says the force of M1 on M2 is 125 newtons. So what that means is that M1 is pushing against M2, call this force M2, and that is 125 newtons. Okay, so that's actually important because the first question wants us to find the acceleration of the boxes. So here's the cool part is M2 here, if I look at all the forces acting on it, I know it has a force of gravity acting downward, which would just be m2 times gravity, but it also has a normal force acting upward, and that normal force would just equal the force of gravity because there's no other vertical forces acting on this thing. And because of that, these are the only three forces. I can actually go after part A and say, well, the acceleration of box 2 would be the force on box 2, basically F12 over the mass of box 2. So that would be your 125 newtons over the 34 or the 87 kilograms. And boom, you've got the acceleration. I'm not going to calculate it, you have to finish it. Here's the cool part. The acceleration of box number 2 is the same as the acceleration of box number 1. So this accelerates at the same rate as this one. And in this situation, the acceleration of these boxes would be the same. Because if I kind of work my way back to do part B of this problem, I'm trying to figure out the pushing force. I'm going to call it FP. Here's the way I'm going to think of it. This pushing force is acting on all of the boxes here, and it's acting on all of the boxes there. So it's acting on the total mass of 87 plus 34, whatever that is. So let's see, 91, 121 kilograms. So it's acting on 121 kilograms. So when I'm trying to find the pushing force, since that's the only force accelerating this, I can actually take the mass of both boxes, the sum, and multiply it by the acceleration that you just found. So I can plug that acceleration in there, put in the total mass, boom, I've got how much total force I'm pushing with. So that's kind of the main idea there. Now, last but not least, C wants what is the force of M2 on M1 in situation B. So we're coming over here. They're realizing if I push them, if I flip the boxes, M2 is going to push into M1 with a certain force. So we're trying to find F21. Now my first instinct is, isn't it just 125 newtons? Wouldn't it be the same? But it's not, because the same pushing force first has to accelerate mass 2, and then some of that force, some of that pushing force is left over to accelerate mass number 1. So if I kind of borrow what I did with this one, I have F12, I have a weight acting down, I have a normal force acting up. Those are not doing anything. This force is causing mass number 1 to accelerate at that same acceleration. So this value I find gets plugged right in there. Okay, so I thought that was kind of a cool one. It harps back to our physics girl video where she was pushing cows into each other. And so I thought it was a good one to kind of think of and kind of go through. Hope you enjoyed.